All right, welcome everyone to the last section for this particular chapter, looking today now at solving radical equations. So we've learned a lot about how to simplify radicals, how to use rational exponents in place of radicals, and now we're going to put this all together in the algebra world and solve equations with them. So let's go ahead and take a look what we're going to do. First examples here today are going to be for the solving index of 2. So that means the square root. Oops. All right, so we're going to be looking at square root equations. We need to remember, as always, when we are solving an equation, we need to isolate something. So the first thing that we're going to isolate is the radical piece, so the piece with the square root. After that, in order to undo a square root, we need to square both sides of the equal sign. Once we square both sides, we need to double check our answers and make sure that any of the answers that we get, they work and we don't get extraneous results. So looking at our first example, we're going to be looking at a very simple example of 3, oh goodness, plus the square root of x is equal to 10. So that's our very simple example. So we're going to follow our rules here. We're going to isolate the variable. So we are going to isolate the radical. We're going to subtract 3 from both sides. We're going to be left with the square root of x is equal to 7. And then we are going to square both sides. So this is this idea of squaring to undo a square root. When we square both sides, we get x is equal to 49. And we have our answer. If we were to do a double check of that solution, we would say 3 plus the square root of 49. And we want to know, does that equal 10? And if we find the square root of 49, we know that is 7. And 3 plus 7 is exactly 10. So that is the correct solution for this problem. Let's try another one. Let's go ahead and say we have 2 plus the square root of 3x minus 2 is equal to 6. All right, so the radical is not isolated yet. It has something on the outside, and that is a plus 2. So we need to subtract 2 from both sides. When we subtract 2, we now have that radical isolated. We're going to get a 4. And again, in order to get rid of the radical, now that it is isolated, we need to square both sides. When we square a square root, they cancel, and we are left with a 3x minus 2 is equal to 4 squared, which is 16. And then we get to go back to simple algebra and solve for x. We're going to say add 2, so we get 3x is equal to 18. We're going to divide by 3, so we get x is equal to 6. And as always, we want to do a quick double check of our results. So we're going to say 2 plus the square root of 3 times 6 plus 2. And hopefully this comes down to 6. So we get 2. Oh, that's supposed to be a minus 2. Sorry about that. Okay. 2 plus 18 minus 2. 18 minus 2 is 16. Square root of 16 is 4. And of course, that does equal 6. So we get the right answer. This x equals 6 is our solution. Let's solve one more like this before we move on to the more challenging problems. Let's look at 2 times the square root of 5x plus 1 minus 3 is equal to 0. Or, sorry, let's make that minus 12. Wrote that wrong. Minus 12. All right, so we need to isolate the variable or the radical, which means we need to get rid of everything on the outside. So everything on the outside of this radical is that minus 12 and that multiplying by 2. So we have to add first. We're going to add 12. We're going to get 2 times root 5x plus 1. That's equal to positive 12. We are then going to divide by 2 and divide by 2. So we get the root of 5x plus 1 is equal to 6. And now we have the radical isolated, and therefore we can square both sides to finally solve for x. So squaring the square root, we get the 5x plus 1 by itself equals to 6 squared, which is, of course, 36. Minus 1, we get 5x is equal to 35. And dividing by 5, we get a very simple x equals 7. Now, of course, you'll want to check that number, make sure it works, which it should in this particular case. So let's take a look at more complicated types of problems that we're going to be seeing today. This is going to be solving radical equations with rational exponents. So not just square roots anymore, but problems with different types of exponents like we learned in the last lesson. So we're going to do the same kind of idea. We're going to isolate the term with that rational exponent. And then this is the new piece. We're going to raise each side of the equation by the reciprocal of that exponent. And the reason we're going to do that is this. If I had x to the power of 2/3 and I raised it to the power of 3/2, this property right here says that we are going to multiply exponents. So we get 2/3 times 3/2, which gets x to the power of 6/6. X to the power of 6/6, which is equal to x to the first power, which is just x. So that's why we're going to use reciprocals of exponents. So let's take a look at examples for this type of problem. First example is going to be 2 times x minus 2 to the 2/3 power. And that's going to equal to 50. All right, so we need to isolate the expression with the exponent, and that is this piece right here. So we need to divide by 2 and divide by 2. So we're going to get x minus 2 to the power of 2/3 is equal to 25. So here is the new piece. We're going to raise both sides by the reciprocal of the exponents. This case is 3/2 and 3/2. Now, this piece right here comes into play. When you take the even root, you must deal with the absolute value of the variable side. So in this case, we have x minus 2. So when we take this, because this is an even root, this becomes the absolute value of x minus 2. The reason that is because we're going to get two different answers here. Then we get 25 to the 3 halves. And as you recall from the last lesson, if we say 25 to the 3 halves, that means I can take the square root of 25 to the 3rd power, which means I can take 5 to the 3rd power, which is 125. Now, if you recall solving absolute value equations, if you solve an absolute value statement, you get 2 different answers because we're looking at distance from 0. So x minus 2 is equal to 125, and x minus 2 is equal to negative 125. Now, I do want to remind you this is only for the even denominator problems. So on this red 3 halves, that even denominator requires us to do this piece. So if I add 2, add 2, add 2, and add 2, we get x is equal to 127, and x is equal to negative 123. Now, of course, you're going to want to check both of these answers. To save us a little bit of time, I know both of these answers work, so we're going to take our word for it on this case. But you want to make sure that you check your own results as you continue. All right, let's go ahead and look at one more just like that last one. In this case, we're going to say 2 times x minus 2 to the power of 2/3. Sorry, not 2/3. I wrote the wrong problem. Let's go with 2 times x plus 3 to the power of 3 halves minus 3 is equal to 51. So we need to isolate this piece here. So we're going to add 3. We're going to have a new 2 times x plus 3 to the 3 halves is equal to 54. We need to divide by 2 and divide by 2. (54) divided by 2 is 27. And now we get to do that new step of raising both sides to a new exponent. The reciprocal of 3 halves is 2/3. And because this is an odd denominator, we do not need to worry about the absolute value in this case. So on the left side, we just get a simple x plus 3. And again, thinking of what we did in the last lesson, 27 to the 2/3 is saying let's take the cube root of 27 and then square it. The cube root of 27 is 3. And then we're looking for 3 squared, so we get an answer of 9. And look at here, it comes very, very nice. We get x is equal to 6. All right, that's the last one for this type of problem. And we're going to look at the third and final type, or kind of the third and final type of problem in these cases. We're looking at problems that have 2 rational exponents or radicals. But the problem is I missed one type of problem that you're going to get, and I want to make sure I really get this one, is a problem that looks like this, where we have radical x minus 3 plus 5 is equal to x. And notice we have 2 variables in this particular case. Now, I didn't really make its own slide for this type of problem, but this type of problem requires us to end up being actually needing to FOIL. So we're going to minus 5, we're going to minus 5. And when we get this, we get the square root of x minus 3 is equal to x minus 5. Now, when we square both sides, I actually have to square both sides. And notice that the right-hand side is x minus 5 squared, which means you must FOIL. So the left side becomes just a simple x minus 3 because the square cancels the square root. And the right-hand side gets FOILed into x squared minus 10x plus 25. And now we get to go back to one of our previous chapters, our previous lessons. We're going to minus x, we're going to minus x, and we're going to add 3, and we're going to add 3. We need to solve quadratic equations by setting it equal to 0. So we get a new equation of 0 is equal to x squared minus 11x plus 28. And as with all quadratics, we're going to factor in order to solve. Two numbers that product to 28 that will sum to 11 are negative 7 and negative 4. So that means x is equal to 7 and x is equal to 4. But what you'll notice is if you plug in certain numbers here, if you plug in x equals 4, you get the square root of 4 minus 3 plus 5, and we want to know, does that equal to 4? Well, 4 minus 3 is 1. The square root of 1 is 1 plus 5 equals 4. And notice 1 plus 5 does not equal 4. That means this is the extraneous answer. And when you plug in 7, you will get the correct answer. That means 7 is our correct result. All right, with that example, now we can move on to that last piece that we need to discuss, and that's where we have two rational exponents, or the same idea as two radicals. So the idea here is that you're going to isolate one of the expressions and essentially solve as before. We're going to take powers of both sides, and let's see what that's going to look like on our example. Now, these are more complicated examples, so this one's going to take us a couple minutes, probably a little bit longer than the last couple problems. So we get x, 2x, oh goodness. We're going to get 2x plus 1 to the 0.5 power minus 3x plus 4 to the 0.25 power, and that's going to equal to 0. Now we need to isolate one of the expressions, so we are going to add this thing to both sides. And we're going to get a new equation that says 2x plus 1 to the power of 0.5 is equal to 3x plus 4 to the power of 0.25. Now, we need to take some power of both sides that will cancel out both of these exponents. If you recall that 0.5, this should be an obvious statement to us. 0.5 is equal to 1/2, and 0.25 is equal to 1/4. And if I multiplied both of these by 4, I can cancel the fractions. So that's essentially what we're looking at. If I raised both sides to the 4th power, notice here we're going to get 2x plus 1, and 0.5 times 4 is 2. And over here we get 3x plus 4, and 0.25 times 4 is 1, so it just becomes 3x plus 4. But notice again, we have something squared which requires us to FOIL. So we're going to FOIL this. 4x squared plus 4x plus 1 is equal to 3x plus 4. And we're going to solve as we did a moment ago, where we made it equal to 0. So minus 3x and minus 4. We got minus 3x and minus 4. We're going to get a new statement again, saying it's 4x squared plus x minus 3 is equal to 0. And as all quadratics, we're going to factor. So we're going to say it is oops, not 2. It is 4x and x. That has to be a 3, and that has to be a 1, and then that has to be a plus. Now, obviously, you've learned ways to factor these problems. Hopefully, you can remember how to do them. And if we solve both of these statements, that means that x is equal to 1. That's the easy one. And here, if we subtract 3, divide by 4, we get negative 3/4. And save us a little bit of time, if you notice, if you plug in a, oops, I wrote these signs wrong here. Goodness gracious. That is supposed to be the minus piece. And this is the positive, which means x is equal to positive 3/4 and negative 1. But if you plug these numbers in, you'll notice that this does not get the right answer, but the 3/4 does. And that's our only solution in this case. All right, I think that was a lot of stuff, and I think you need to absorb it now, and I hope you learned a little bit. I'm going to leave us with this, and I will see you guys later.